Force vector is given as 6i cap minus 8j cap, 2 dimension, acts on a particle and displaces it over 4 meters along the x-axis and 6 meters along the y-axis. The work done during the total displacement is. So given data, force vector is given as 6i cap minus 8j cap Newton, and displaces it over, the displacement vector is how much portion it has covered on x-axis? 4 meters on x-axis. On x-axis vector is I cap. So this is 4 I cap. Not only x-axis, it also covers y-axis. So body is taken x-axis as well as y-axis. So somewhere the body is there. So it is carried towards y-axis. It also moved toward, covers a distance along x-axis. So on x-axis it covers a distance of 6 meters. So plus 6j cap. What is the value? Plus 6. 4 meters on x-axis, 4i cap. 6 meters on y-axis, plus 6j cap. If the same along negative y-axis, then we have to take it as minus. Okay. Therefore, the work done must be equals to W equals to F bar dot S bar. What is F bar, children? 6i cap minus 8j cap dot S is equals to 4i cap plus 6j cap. So, multiplying together 6 4s will be getting 24 minus 8 times of minus plus 6 will be getting 48. Hence, the correct option is minus 24 joules. Therefore, option 3 must be true. So, negative work is said to be done. So, moving ahead with the next question, children. 13th question. A lawn roller is pulled along a horizontal surface. What is the direction of the lawn roller? The lawn roller is pulled along a horizontal surface through a distance of 20 meters. So, what is the distance covered given? 20 meters. By a rope with a force of, so some force is also applied on this, and that force is given as 200 Newton. If the rope makes an angle of 60 degrees with the vertical, this is important, children, 60 degrees with the vertical. So, makes a sense. First of all, let us imagine the picture, a lawn roller. Okay. So, on this lawn roller, some force is being applied, and the force acting on this lawn roller is 200 Newton, makes an angle 60 degrees with the vertical. Well, the direction of force, let us suppose that this is pulling force F, and this is your vertical. Lawn roller is pulled along a horizontal surface. Pulled means displacement. Displacement is along horizontal direction. Distance of how much it is given as 20 meters. By a rope, some rope is attached with a force of 200 Newton. How much force is acting on that? 200 Newton. If the rope, where is the rope? Okay, some rope is there, and if the rope makes an angle 60 degrees with the vertical. So, here is the rope, the person is holding this rope and trying to pull this. Okay, so the rope is making an angle 60 degrees with the vertical. 60 degrees with the vertical, not horizontal. Okay, if 60 degrees with the vertical, then what is the angle with the horizontal? It must be 90 minus 60, so that is 30 degrees. So here angle made by the rope with the horizontal is 30 degrees. Don't get confused, children. So with the vertical they gave it as 60 degrees, but we always measure the angle with respect to horizontal. If vertical 60 means horizontal it should be 30 degrees, 90 minus 60. So all the values of F, S and theta are known, and the amount of work done you are asked to find out. Work done formula F S cos theta. So this is equals to F is 200, S is 20 and cos 30 degrees. Therefore, this is equals to 200 into 20, cos 30 is equals to root 3 by 2. Now simplifying further, this 2 goes 10 times and hence the final value of work done is 200 into 10 is 2000 root 3 joules. So where is the correct option, children? Option 3 must be true, that is 2000 root 3. So moving ahead with the next question, 14th question. Here also force vector is given, displacement vector is given and you are asked to find out the work done. So work done formula is equals to force vector dot displacement vector, or W equals to force vector is taken as I plus 2j plus k multiplied with 4i cap plus j cap plus 7k cap. So multiplying further, we'll be getting work done equals to I means 1 into 4 you are getting as 4 plus 2 times of 1, 2 and 1 times of 7 you are getting as 7. Therefore, the total work done is 6 plus 7, that is equals to 13 joules. Second option is true. Getting me, children? Well, moving to the next question, that is 15th question. Work done by the gravitational force on a body of mass m moving on a smooth horizontal surface through a distance s. Well, so where is that? The gravitational force are given on acting on a body of mass m. So where is it acting? On the surface. Consider a body. Consider a body. On the body, the direction of the gravitational force is downwards and the body is pulled horizontal to the surface. In this case, this is the displacement, direction of displacement, this is the direction of the force. In this case, angle between the displacement vector and the force vector is 90 degrees. Whenever angle between the two vectors, force vector and displacement vector is 90 degrees, work done is given as Fs cos 90 degrees and this will be 0. So what is the correct option, children? The work done on this is taken as 0. Okay. So now moving to the next question, that is 16th one. A body of mass 1 kg is made to travel. A body of mass 1 kg is made to travel with uniform acceleration of 30 centimeter per second square. Here is in SI, here is in CGS, over a distance of 2 meters. So work done must be equals to, formula for work done, W equals to F dot S. But directly the force is not given, where the force F is equals to product of mass into acceleration. Therefore, the value of work done equals to MAS. Substituting all the values, mass is taken as 1 kg, acceleration is taken as 30 centimeter per second square and displacement is taken as 2 meter. Here it is in SI, here it is in SA, but here we have an CGS system. So let us convert everything in SI system so that you can go with the answer. So 1 kg multiplied by 30 centimeters to be converted to meters means you have to divide with 100 meters per second square into 2 meters. So simplifying further, you will get 0, 0 gets cancelled. So you are left with, what is the correct answer, children? 1 into 3 is 3, 3 into 2 is 6, 6 upon 10. Units here is kg, meter into meter, meter square per second square. So this is equals to 6 upon 10 is 0.6. Instead of kg, meter square per second square, you can represent with J, joules. Therefore, the work done on this mass is nothing but 0.6 joules and hence option 3 must be true. Over. Moving ahead with the next question, children. 17th one. A uniform cylinder of radius r length L and mass M is lying on the ground. What was the object? Cylinder. With the curved surface touching the ground. Let us construct the picture. Cylinder. So this is how a cylinder looks like. A uniform cylinder of radius R, length L, mass M lying on the ground with a curved surface. This is the ground. A cylinder is being kept. Okay. So, uniform cylinder of radius R and length L and mass M lying on the ground with the curved surface touching the ground. So, this is your curved surface. So, this curved surface is touching the ground, whose radius is given as R, length is given as L. This is what is given, uniform cylinder of radius R and length L, also having mass M, is lying on the ground with the curved surface touching the ground. If it is to be oriented means it has to be, its direction should be changed. Oriented on the ground with the flat circular end in contact. So, now it is in the horizontal position. Now we have to make it stand something like this. Then the new position of the cylinder will be something like this. So, earlier it was in sleeping position, now it is in standing position. Whose mass is M, radius is R and length of the cylinder is L. Over. With the flat circular end in contact, the work done to be done is, so in lifting the cylinder to making it straight, so we are doing some work because some force is applied on that. So, how much work is done? You have to identify how much work is done on this cylinder. To find out this, we know the formula for work done is force into displacement. So, how much force is acting and how much displacement. So, work done on the cylinder is generally formula is force into displacement. The formula for force is weight of the cylinder. You have to lift that cylinder to make it straight. So, force acting on the cylinder is nothing but weight of the cylinder. F equals to ma or F equals to weight mg. Whereas the displacement is, earlier this was the position L and now this was the position L. Okay, so the center must be lying here and this center has to be brought here. So, some difference in the height is being made. So, this is nothing but displacement. Displacement is nothing but this height h1 and this height h2. The difference in the heights is nothing but the displacement. So, clearly the value of S is equals to new height minus old height. This is the displacement we have brought in. So, what is the new height, children? The new height will be the center of position. The whole weight of the body is supposed to be acting at its center and this height is nothing but half of its length. This is L by 2. So, how much is the displacement? H2 is equals to how much? L by 2 minus. Now, initial position of the center of mass is H1. How much is this, children? This is equals to its radius. So, L by 2 minus R is the value of S. Substituting here, we have S can be written as L by 2 minus R. So, what is the formula? Work done in lifting the cylinder to making it straight is equals to mg times of L by 2 minus R. So, option 1 must be true. This position is now brought to this position. Some difference in the height is being observed and that difference in the height is nothing but h2 minus h1 and that is your displacement. So, h2 is L by 2 because total height is L, half of the height is L by 2 and h1 is R. That's it.